All right, and we are live. So today we have ourselves a MacBook Air. It's an A1466 model, manufactured between 2012 to 2017. Looking at the SPI connector on the logic board, and also going off the board number, which is an 820-00165. This tells me this is either going to be a 2015 model or a 2017 model. We can confirm by checking the serial number, but all I need to know is that this is a 820-00165. This MacBook's in here because it just isn't turning on. Customer went to go use it one day and has no signs of life. So I've gone ahead and hooked up my voltage and amperage meter here, our power supply, and we're going to check and see how much amperage we are drawing. So whenever I connect the logic board here, we are currently not reading anything. Why is that? A little technical difficulty already. Let's find out what's going on here. Okay, there we go. Okay, so we're pulling 0.029, which typically means that we are missing our SM sleep or PM SM sleep PM S4L line. It's been a minute since I've done this line in a minute, so I know I'm saying that wrong. But if you look real quick with our amperage right here, it is going to try to spike. It looks like a second ago it went to 0.01 as you just saw. So that usually means something is trying to turn on, but then there's immediately a short or something isn't communicating properly. So PM sleep S4L is going to be a very important line that is responsible for kicking a MacBook Air out of sleep mode. So our computer is always going to be in different states. So we have our S5, S4, S3, SO. S5 is going to be that the computer is off, but it's hooked up to power or it has the battery connected to it. S4 and S3 is going to be that the computer is either in sleep or hibernation mode. And S0 or SO is going to be that the computer is fully turned on, processor's going, and Mac OS is starting. Missing PM sleep S4L is going to be a situation that the computer is stuck in an S5 state and it's never transitioning to an S4 state. Excuse me. And so that's going to be one of the first things I do real quick is check, measure PM sleep S4L. I've already gone ahead and I found some corrosion on the logic board, but I just want to show you what we'd be looking at if we were just reading the schematic. So if we go over here, we're going to do a quick search for PM underscore SLP underscore S4. And now let's check and see where that is located. These are all the different spots where PM sleep S4L is located on this logic board. And you can see it goes to a couple of important things. Like we have ourselves here the processor. Over here we have our system management controller or SMC.
So it is ready for pickup at any time. All right, thanks.
And all sorts of various signals right here. So let's go ahead and take a look at this real quick underneath our microscope. So I'm going to start with Q2090, which is going to be right next to our battery terminal, and see what we have. In fact, let me orient this on the screen to match up with how I currently have the logic board. So now let's switch over to our microscope camera. And so there's our battery terminal, and there is where we would have something populated, but we should still have a voltage. I still don't have my multimeter from home that has the Bluetooth reading to where you guys can see what I'm seeing. So you're just gonna have to trust me based off my measurements here. So I'm gonna go ahead and put my multimeter into voltage, and I'm gonna measure where that particular point would be at. And we have 0.0 volts. So that just confirms that we are missing PM sleep S4L. Now we could go through all of our power aliases, such as PP bus, our PP342, G3 hot, our 5 volts S5, our 3.3 volts S5. But let's go ahead and do a visual inspection. Was long ago to see you. It's been a minute, so I appreciate you guys while we've been doing other repairs that I just haven't been able to actually live stream them. So let's go back and do a quick visual inspection. So from here, everything looks perfectly fine. However, if I flip over the board, there's a little bit of corrosion right here. Try to bring that into focus. And that's a pretty important chip. Let's get a better look. Right there. So it looks like we have some oxidation buildup from being in a humid environment. Now, we are in South Carolina, and South Carolina is kind of the armpit of America. It is very humid here. So a lot of the times people will just bring in computers that were working perfectly fine, just decided to turn off. Ultimately, it's because the sheer humidity in the atmosphere is building up condensation on the logic board and ending up killing them. And I think that's kind of what's going on here in this case. So what is this chip? That chip right there, that looks pretty important. So I know what that is, but just to show you what you guys would look this up, we're going to go over to our Flex Board View software here by Paul Daniels, if I can pull it up on the right scene. And I have the board flipped over, so it looks like this. All right. So all of our corrosion is in this area. Now this is a pretty big chip, U6100. So what exactly is U6100? Let's go ahead and pull up our schematics right here, and it says it's pretty critical. But what exactly is U6100? These are all things that say place near U6100, but show me where U6100 is. Right here, U6100, SPI ROM. So for those who are more familiar with PC repair, our SPI is going to be the equivalent of a BIOS chip. So that is what's responsible for actually loading just the information of how the logic board works, the BIOS. On Macs don't really have BIOS, they have EFI. In fact, most modern PCs no longer really have BIOS. Most of them come with an EFI type of situation, or instruction set of how the motherboard turns on. Or as David sings, UEFI. I forget what the U stands for. I think it's unique. I could look this up, but I don't want to get off track. So the UEFI chip is what's responsible for the logic board to work. What tells other parts of the logic board, hey, turn on, hey, when it turns on, boot into a different, like a specific operating system on the logic board. But Apple doesn't call it a UEFI chip. They call it specifically an SPI chip. So that seems pretty important for us to not have corrosion near it. There's also another important chip right next to it as well. So if we pull it back up right here, this is unscathed. That seems to be fine. But this is going to be our clock chip. And David says it's Unified Extendable Firmware Interface is what UEFI stands for. That sounds pretty important to me. So if we go back to our logic board, as I was mentioning, this is our clock, U1900. Now this is another chip that is responsible for turning on the computer. It's a clock, and as clocks do, they keep track of time, but they also keep track of the rate of when power and data communication can talk to other chips on the logic board. So that could potentially have an issue, but also all of the corrosion here is the issue. So this is a very long video to basically say, hey, there's stuff. There's just oxidation and corrosion all over these resistors. Let's go ahead and just replace, or as I've had other people say jokingly, let's be janitors and just clean up the mess. We're just board janitors here. We're not doing any logical thinking. We're just simply repairing the obviously corroded and damaged components. And just for the fun of it too, let's see exactly what those resistors are. So there's 4 of them in particular. And if we look at them, these resistors are responsible for communicating the SPI main logic board clock. SPI clock, SPI alt current sense low, and SPI, I would imagine main logic board current sense as well. So this is going to be current sense, what's responsible for figuring out if the UEFI or the SPI chip is pulling too much amperage, and it's also going to be the clock. Now, if we don't have a clock, then our SPI is brain dead. It's not able to communicate to other parts of the computer. So hopefully, just by simply cleaning this up, replacing those 4 resistors, we get ourselves a working MacBook. Let's go ahead and just start working on that now. So, when it comes to corrosion, if any of you have watched my previous videos, what I like to do personally is clean the corrosion first before I start heating up the area with heat. And I clean it. You can use deoxic. That's a pretty popular chemical. I actually don't have any of that with me now. So, I'm going to put a little bit of Windex. That's right, store-bought Windex on a Q-tip. And it's because Windex has detergent in it. And it's going to eat away a good bit of the corrosion, but Windex also has water in it. So you want to make sure when you clean this area up that you remove as much of the Windex as possible so that you don't end up shorting something and having a completely different issue. So what I use for cleaning up the Windex afterwards is going to be a little bit of isopropyl alcohol, because alcohol displaces water. And then after that, we'll use our heat gun to evaporate the remainder of the alcohol. And so this gives me a good starting point of what to actually work on. And for one resistor I actually missed because it was buried in the corrosion, is right here. So there's actually 5 resistors. We can also have these test points can also be corroded. So let's scrape away some of the oxidation. Up here is a via, so that doesn't actually have a like a jumper point where it solders onto any of these resistors. But down here, these test points do. So I'm trying to expose some of the copper just so that we can clean and solder new solder, or if need be, run a jumper wire. And some people will just go ahead and remove these components with the corrosion on. That's fine. Just me personally, I like to go ahead and get a clean canvas to work with before I start soldering. That and flux and rust and corrosion just makes this really thick molasses-like residue, and it makes it a little harder to solder with. So now I'm just going to clean up the area a little bit more with some Windex. Sorry, not Windex. I'm using isopropyl alcohol here. And you can see right here that this part of this via is kind of eaten away. So I'm just going to attach a little wire from here to here, just so we have a nice and steady established connection. Now that this area is nice and cleaned up, let's go ahead and repeal and replace. And I'm going to use, since these are resistors and not capacitors, I'm going to use my micro tweezers, my hot tweezers. And actually, I don't know if you saw that there, but that resistor to the right, I just went over with flux. That's literally all I did. And it's stuck here. It completely ripped off the board. So that would be why this isn't turning on anymore. Well, that wouldn't be the main reason, but basically saying that pad that it was soldered onto is null and void. It just no longer really exists. So let's go ahead and turn on our fume extractor because we don't like inhaling solder fumes, flux fumes. And the nice thing about the hot tweezers is you can just pick up these components and they just come right off. And so, these 4 points, or 8 points, but where 4 resistors would go, seems fine, but you can hardly see the pads where that one would solder onto, that one resistor. So what I'm going to do is I'm going to try to tin it. And tinning is just applying heat with the soldering iron while you run some new solder. Okay, that one's looking better. This side right here. That side I'm not going to be able to tin with all of that corrosion. As mentioned, it makes almost like a molasses-like material when you have the burned corrosion and part of the fiberglass. So we're going to clean this area up with some alcohol, and I'm going to scratch into that pad to try to expose more of the copper, because it's pretty much gone. You could take a wire brush if you wanted to try to expose this. And see, I'm just lightly scraping and it's just turning into rust. I'm trying not to scrape too hard because I don't want to end up damaging what's left of the pad, but I need to at least scrape to remove all the rust. And so, this right here, this is a line that's supposed to go to this test point, and it's just basically severed. Okay, let's clean that a little bit more. And so very tiny, there is a little piece of copper. That is our saving grace that we'll need to solder a resistor onto in order to fix this line. But what we're going to have to do is we're going to have to solder our resistor here and then have a wire, or what we can actually do is go ahead and run a jumper wire from here to here, and then we put our resistor. Let's do that. That seems like that's going to last a lot longer if we were to do that instead. And I don't think I'm going to be able to scrape any more away, not without potentially damaging what's left of this tray. So I'm going to go ahead and stop, and let's clean this one more time. Yep, and that's exactly what we're going to do. So before we put our resistors on, I'm going to go ahead and run some jumper wire on these traces. So let me go grab some jumper wire real fast. And I have two different types of jumper wire. I have a jumper wire that works great for MacBooks, and I have some that works for iPhones. So let me take a look at what I have for MacBook, because it may be too thick for this specific trace. It is a little thicker. Let me see what the iPhone iPhone jumper wire looks like. That's a much thinner wire, but I think that's going to work for us. That way we can lay a foundation for our trace, and then we'll be able to solder components onto it. So let's go ahead and do that. Let's start by tinning what is left of these traces. So what we'll need to do is go ahead and put a little bit more flux. And then just like what we did before, we're going to take our soldering iron. While we're touching the trace, we're going to run a bead of solder through. So I'm going to put a wire there just because that looks suspicious. I'm definitely going to put a wire here, because as I'm heating this up with my iron, it's just melting away what's left of this trace. Okay, and then up here. And then we got to tin that tiny, tiny hole right there. Tiny dot. And we are good for now. Let's go ahead and get our wire ready. Okay. I'm going to start on the left side and work my way over to the right. And I'll do this as best as I can. My hands are shaky just because I've had more coffee today than I normally do. And solder right there. Move it a little bit more. There we go. Okay. Now we got to make that wire more established. So I'm just going to cut this off. So now that I have my trace there, I know it's really hard to see. I'm going to tin it some more so we have more solder. Okay. All right. So that is nice and snug. Could look prettier, but the connection is there. I'm going to move over to this side now. So let's go ahead and try to line this up as best as we can. And you can see my hands are shaking a lot right now, but I'm really zoomed in under the microscope just to give you an idea of how small this trace is. Okay. And then now let's move over here. Come on. All right, and a little bit more right here. Okay. What's that? Just a little bit of solder left behind. Okay, so now that we have that wire, let's go ahead and cut it again. And then just like we did on the other one, I'm gonna tin it some more. So we have a nice solder mound on top of this wire. And see how it's making almost like a mountain instead of a nice mound? It's because we need a little bit more solder, or not solder, a little bit more flux there. Okay. And then we very quickly touch this. There we go. Nice little mound. Okay. And I promise this will look better once I clean up the flux. There's just too much of a reflection underneath the microscope. So now we're going to have to run a wire from here to here. Oops, hands are shaking way too much for this side right here. Let me see if I can readjust. Try to position the logic board a little bit better. And the longer that you solder on flux, it starts to get this very thick, again, molasses or caramel-like state. Okay. And then now I need to try to solder onto that tiny little dot right there in the center. And we're good. So, let me cut this. I'm going to tin this side up too, and then I'm going to clean it. Then we'll be ready to solder the replacement resistors. Okay, we're good there. And let's put a little bit more solder down here into this little cavity. And we're good there. And just so we don't end up bridging this connection, so touch that up. And now let's clean it. Let's clean it so you guys can actually see what we've done here. And so for cleaning it, now I'm using acetone. I've experimented with different chemicals, and I've so far I've learned that acetone works the best for cleaning flux. So you can see here, with the iPhone jumper wire, we have a wire from here to here, here to here, and then from there to there. We're going to put resistors there, and then 4 more resistors over here. So we're finally at a point to where we are ready to solder some resistors, and then afterwards we can use some mask, which is going to cover the jumper wire with like an epoxy resin, so it doesn't break as easy or potentially corrode in the future. Alright, so we need a donor board. So the nice thing about the 820000165 is it actually uses the same components as the, I want to say it's the 3747. Let me see, I got it right here. As a 3437, which is going to be the 2013-2014 MacBook Air. But I have plenty of 820000165, so I'm just going to pull straight from this board, since we know that it's the exact same model. These are the data lines, no power lines, so you can use thin wire. Alright, and let me change the view here. So what I'm going to do in this situation is go ahead, put some more flux, just so we have this area nice and prepped. Now let's go to our donor board. And there are the resistors. And I'm going to switch back to my hot tweezers so we can pull them up one by one. Let's start with the top left. One resistor lined up. One resistor soldered sideways. Let's try to make that look a little prettier. If I can get my hands to stop shaking. There we are. It's a little crooked, but that's how you know it's had some love on it. Let's get resistor number 2. Yeah, hands are just way too shaky today with the amount of coffee. I cut coffee out for a while there. I went probably good 4 months without drinking any coffee, and honestly, I did see an improvement in my life. I did sleep better, I could think better, I wasn't as anxious, especially when it came to making like big decisions with people in business. However, business has been very well, too well, that I've had to start drinking coffee again in order to get enough repairs completed. One of our major competitors in the area decided to close up all his stores, and we have been getting a whole bunch of new clients because of that. It's all been good things here. Another reason why I haven't really been able to do any live streams lately is because, quite frankly, I've been doing a little bit more than just board repair here. We've been doing a lot of iPads. Been getting some mail-ins for iPod Classics. Seems that the last couple of videos I did recently has generated some attention. And yeah, as far as board repairs go, I still get them, but it's a matter of time where I do complete logic board repairs faster when I'm not being recorded, because I can just put some headphones in and just work while listening to some music. But I do like doing live streams. I feel like there's not enough board repair content out there, and of the content that is there, some of it is questionable and probably not good quality advice. Try to get that on there a little bit more. Shaking too much. Let go gently, 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 and we'll go back and we'll touch that up. Too much work is better than no work. Absolutely right. I've been very grateful, don't get me wrong. I've been very thankful for the amount of business that I've gotten. I just need to better balance being able to do live streams from actual doing our walk-in customers, because we do generate mailing clients from YouTube. For those that have sent us stuff, very grateful for you trusting us. We've been getting more repairs from Canada as well, which has been pretty neat. We've had a few people from Ontario send us stuff. And I really don't do international shipping, but shipping across the border to Canada seems to be a lot easier to deal with customs that way. Alright, resistor number 4, and this resistor is on our jumper wire. Perfect, that one looks good. Now, let's solder the last resistor onto number 5. Resistor number 5, which we didn't even look what that one was on our board view, because we couldn't even see it because there was so much corrosion. Names, names, name names. Name names as in what? Clients? Can't do that. Board repair videos? I'd rather not. It just seems that most of the board repair technicians have kind of stopped doing YouTube videos, especially Louis Rossman. I haven't really kept up with any of his videos lately, but it seems to be less content about actual board repairs. But that's a whole nother subject, what he is doing. Alright, number 5. Get that in place. And this one's going to be a little tricky. This one would actually be better to do with a hot air station. But let's see if we can get... Ooh! It's moving just a little too much. Awesome. Now, let's make this look pretty. He is now in Texas. Yes, that I have seen. Because he moved to Texas. Louis Rossman moved to Texas, so I think like 2 years ago at this point. It's hard to keep up. Time has flown by since March of 2020. Okay, our resistors are there. Now, we're going to beautify them. We're going to make them look pretty. Because you can see they're crooked, and you know, it probably works, but I really don't want this customer to come back in the future, so I'm going to apply a little bit of solder onto each pad just using our micro pencil. And then I'm going to use the rework station so that we can kind of melt it all together and it looks nice and pretty when we're all done. So, now that we've applied more flux, or we've got our resistors on there, let's apply more flux. That's the order I meant. Before that, check if function is. I will in a moment. This 5th resistor, since it has a via, and it has traces, and I had to run 2 jumper wires, I really want to make sure I have a nice solid connection. So I'm putting more solder there. Same thing here. Let's touch that up some. This resistor could benefit from some more solder. That one seemed okay, but we're just going to touch it up anyways. And because I don't trust my hands. My hands are too shaky today. So, now that I've touched up, let's go ahead and turn on our quick 861DW rework station. And let's heat this area up. Adamant, it is quite good. Definitely want to make sure that this is a nice solid connection. And so we're just waiting for the solder on these resistors to start to melt. And then surface tension should just pull them straight, or straighter. Okay, so they're nice and melted. Now what I gotta do, this is gonna be a little tricky with my shaky hand, is touch the right resistor. The one on the right. Okay. And see, it's shifting just a little bit too much. But I think we may actually be fine. It's really hard to see, but I can see the jumper wire underneath, and the jumper wire does appear to be touching the via. Let me see if I can touch it up just a little bit more with some solder. And if it turns on, we're then going to apply mask. Oh. That's right. I have my pencil turned on. And breathe. There we go. Just like a sniper rifle. Hold your breath. Get better control. Alright. Let's clean the area up one more time with some acetone. Nail polish remover. Pure acetone. And this is what we have. So that jumper wire down here is making a good connection. Here it's soldered right there, and then I can see this jumper wire is touching that trace, touching that part of the resistor, and I have a giant glob of solder that is holding the resistor to the jumper wire to the via. So, let's figure out if we fixed our MacBook. Go back over to the overhead camera. And this is the logic board jumper wire I like to use. It is 0.02 millimeters. However, in this case, just because we were zoomed in so tight, I actually opted in for what I use for iPhones, which is 0.009 millimeters thick. Very, very small. Let's see if this is going to turn on with our power supply, because if you watch previous videos, this cable in particular has been giving us issues. Do need to just cut up another wire. And, moment of truth. See what we get. 0.029, 0.4, 0.5, and that should be booting amperage. We're getting a whole entire amp, which means our PM Sleep S4L line has been resolved. So, just a quick little synopsis. We found a little bit of corrosion right next to our SPI. Yes, good job, thank you. We found a little bit of corrosion right next to our SPI, which is the UEFI on a MacBook Air. It's the fancy way of saying what BIOS used to be. And if we go back over here to our schematic, we can see it was around U6100, which is our UEFI, and we had 5 resistors in particular that were just completely corroded. And we can see when we click on all of them, they all say something to do with SPI, like our SPI clock, SPI alt clock, current sense, and over here, machine in, slave out. I don't know what the terminology for that is. All I know is that is very important when it comes to UEFI communication. So now, before I fully end this video, because we should have fan spin in theory, I'm going to plug this in to the frame and see if we even get an Apple logo. And then that will be that. So let's go ahead and stop our DC power supply. Make some room over here. And plug this back into our frame. And I'm going to clean it up too, just because it could look a little bit better. So, overhead camera. And going forward, would you guys like these live streams, or would you want me to start focusing on how-to repairs on other repairs? For instance, I have a iMac graphics card. It's a A1312. Sorry, can't think right now while I'm also putting this in. So my most popular video here on YouTube, it's got over 80,000 views. It is the A1312 2011 iMac graphics card replacement. And the reason it's so popular is because it's more of a how-to video instead of just ranting to the string and kind of going through my thought process of how I fix this. It's more of a, hey, this is how I know how to fix this. This is the process of how you would do that. Do you feel that has more value? How-to videos, let's say an example, how to properly replace a battery on an iPad screen, or how to go about replacing a clamshell of an A2337 2020 MacBook Air? Or would it be better to just keep doing board repair live streams or board repair videos in general? What content do you think would be better generated for YouTube? Let me know what your thoughts are, because the board repair scene it seems to have less and less people watching, but the how-to videos seem to be more for a broader audience. I'm open for any opinions, suggestions. Phil says keep up the good work. Thanks, Phil. I appreciate that. Because the board repairs are fun. Don't get me wrong, I enjoy doing board repairs. I do a lot more than just board repairs here. Okay, so I'm not going to worry about connecting our Wi-Fi. I do need to, of course, plug in our solid-state drive just so that we can get an Apple logo. And why not? We'll go ahead and we'll plug the battery in too. That way we're not thermal throttled. Okay. And like the old videos used to be, do we have fan spin? We do have fan spin. Do we have backlight? Alright, screen just flashed. And when we have an Apple logo. Oh, let's see. Probably the battery's dead. Let's give it a second. Don't want to dox anyone, but we have an Apple logo. So that is a successful MacBook repair, and we are at the login screen. So there we are. MacBook Air dead by a little bit of humidity damage from the atmosphere that is South Carolina. So I appreciate you all joining me. I've had a couple of people here on live stream. I greatly appreciate it. I have some more board repairs. Probably not going to live stream those just because I got to get those done in a timely manner. I may stream a A2337 that we have here that does have a short on the main power lines. So combinations, but all good. Awesome. We'll probably mess around with both different types of video formats. But anyways, this video has been going on for... it doesn't tell me anymore. Okay, we've been streaming for 46 minutes. So that's it. Thank you so much. You guys enjoy the rest of your week. Have a great day.